Hey, I'm Rebecca Burke-Aguero. I'm a senior product manager on the Mesh Developer Platform team.
Hello, and I'm Norbert Nemetz. I'm in the Havok team working as lead developer for Mesh Physics.
By the end of the video, hopefully you'll know not only what is Mesh Physics, but why you should use it and how you should use it in your Mesh custom world. Let's start with what is Mesh Physics. So like physics in the real world, Mesh Physics is the set of rules and properties that govern the way that things move in Mesh. But unlike physics in the real world, Mesh Physics, you as a Mesh developer, you have the power to rewrite those rules. So as part of the Mesh Toolkit, Mesh Physics aims to empower Mesh developers to be able to easily create interactive, intuitive, and shared content that just works. So let's break down that definition one word at a time. And let's look at examples from the Science Museum, which is a sample that we provide to you as part of the Mesh Toolkit. So Mesh Physics, as a Mesh developer, it's your job to create the types of content that really interact and engage your audience. And a really easy way to make really engaging content is through shared interactions. So whether it's things like games, like air hockey, or puzzles, here we see a puzzle where you're trying to get a ball into a bucket, or it's things like simulations where you have to guess the mass of a mystery block. Or even just dynamic elements like interactive art in your experience. Like all these types of physics-based interactions are a really easy way to add life and create interactions into your scene. So interactions are very powerful, obviously, but what makes physics an intuitive way to add those interactions? So with this penguin example, when I pick it up and I drop it in Mesh, and then I drop it into water and it floats, like these behaviors are mimicking what I expect in real life. Physics is an intuitive and understood language that needs no explanation. So when your Mesh world follows the laws of physics, it instantly adds immersion and realism to your experience. So things in your experience need no explanation, and folks can forget about the medium a little bit and really just get immersed in the storytelling or the content of your experience. Conversely, you can consciously choose to bend or break the laws of physics. So things like speeding up time or slowing down time in simulations, or like in this example, playing with things like mass and gravity and sending a skateboard into orbit. And also because the world is physics-based, that allows for emergent, non-deterministic behaviors to exist, which are really hard to program deterministically. So that keeps your world fun and engaging, and that sparks creativity even after many repeat visits to the same environment. Okay, so we've talked about interactive and intuitive. But what is the power of sharing these interactions? Well, like everything in Mesh, Mesh Physics is better when it's shared. In physics-based interactions, as we talked about, it's an intuitive language that is already understood. You can communicate without words, and it needs no explanation. So in things like team building exercises, icebreakers, all hands, like trainings, it creates an automatic entry point to these activities. And even the most introverted members of your team can participate without words. And then your discussions are also made more tangible and more fun, honestly, when you're working towards a shared problem together. Okay, so we've talked about the value of Mesh Physics, but how does it actually work? So Mesh Physics is based on a C++ core and a C# based set of effects that developers can choose from. So talking about the core first, Mesh Physics supports the full set of client-side Unity physics, and it integrates with Mesh scripting. It's also based on peer-to-peer synchronization, so you don't need any server logic to make mesh physics work. And then any hiccups in the network are also automatically handled for you, so you don't need to worry about that either. And then finally, mesh physics is super scalable because it's a very, very minimal CPU impact on the client, and then also very, very minimal bandwidth impact. So talking about effects, this is just a super small subset of the effects that we provide to you. There are many more in this list, but you saw some of these already today in these examples. So every time we saw the planets, that was orbital gravity at work. Air hockey is supported by alignment fields and containment fields. And then, of course, buoyancy with all the ships examples. So many, many more effects to talk about. A really great way to explore these effects is through the Physics Effects Gallery, which is another sample that we provide as part of the Mesh Toolkit. And it really simply breaks down these effects individually and then also in combination. So you can see how they work in different ways. So for example, this is one exhibit that just displays how spherical explosions work. And there are different examples, and you can reset the positions. Or you can see how they work in combination in really interesting ways that require collaboration to solve. So this is a balance table that two people control, and the objective is to get the ball in the hole. But you need two people to accomplish this. So similarly, there's a little race car game, that you need two people to control the race car. One person controls steering, one person controls acceleration. And of course, the remote control car itself is based on mesh physics. So these kinds of examples are free for you to explore and to take elements from, and also hopefully get inspired from. But rather than me continuing to just talk about mesh physics, how great it is and how it works, let me hand it over to Norbert to walk us through a Unity demo of actually using mesh physics.
Yeah, thank you, Rebecca. Let's look into how to build something with mesh physics. So what I have prepared here is simply an empty scene set up to get working. There is just a bit of static content. There's lighting, some static bodies, but nothing happening yet. The first thing whenever you want to start working with mesh is to add this play mode setup to have a camera and have an avatar. So here we can see this is Anna. Anna currently is an empty world. You can press play, takes a moment, and after a moment, Anna can walk around in the world, look at the things. You can check whether perspectives work, whether the scene has the right lighting, everything. But yeah, after a while in a static world, Anna simply gets bored. There's nothing there to do. So let's at least add someone to communicate with. Anna needs a friend. Play mode setup allows us to simply add a second screen and get simulation of a shared experience right for a single developer. And now Anna has a friend. Meet Bob. On the left side, it's Anna's view. Anna sees Bob. Bob looks back and sees Anna. Anna and Bob can explore the world together. They can see each other. They could, in principle, talk to each other. But again, it's a static world. There's nothing to do here. Anna and Bob get bored. So let's give them something to do as well. What we do now is to add just a few cubes to start with. Nothing much, just a few cubes. They are static at the moment. Let's make them dynamic by adding a standard Unity rigid body to each of them. And yeah, let's try it out again. Anna and Bob can play with cubes. Yeah, you see the cubes falling down. Anna and Bob can see the same set of cubes. Anna can observe Bob. Anna can bump into the cubes, tip them over, and you can see that both have fully synchronized physics. You can observe how the scene is synchronized between two players. But right now, I mean, this is good for a bit of slapstick. You can bump into the cubes. You can't interact with them yet. So let's make the scene actually interactive by making, in this case, simply the default mesh interactable setup allows us to, with one easy addition, make all the bodies, all the rigid bodies underneath this interactable or manipulable in this default setting. And immediately the world gets more interactive. Anna, well, here now, Bob can lift up something. Anna can come by, can topple over the tower. Again, Bob can start piling it up again. So you see, with just a few shapes, you can already create the very simplest set of children's toys to play with. No logic needed. Let's make it slightly more interesting by adding one of our effects. So here we have another prefab that we can add. At this moment, this is just a static piece of a static block with a word on it. We can, as before, make it dynamic by adding a rigid body. And in this case, also add one of our mesh effects, the sticky body. So this is a mesh extension, which allows the body to stick to whatever you hit with it. Right. And like all of our mesh physics effects, this is immediately synchronized between the players. So it works out of the box. Bob can pick this, place it to one cube. Then Anna can take the entire cube and put it somewhere else. So all of these effects simply work out of the box, are fully shared between the players, and can be combined in creative ways. To take this one level further, build a small game from this. So we have this one tiny game extended here, which is essentially the same as before, just multiple times. So there are simply more than one word. Each of them already has a rigid body, sticky body attached. Nothing magic behind this. And the first mini game is ready to play. Now, Anna really loves poems. She loves words. She loves playing with words. Anna has no idea how to turn this into a poem. So Bob comes along, looks at the words, sees, okay, who needs this? Takes something else out. 7 tiny avatars. Now Anna jumps in, gets creative. She gets inspired. Takes something else out. Are ready to be, and then Anna runs out of ideas. 7 tiny avatars are ready to be. Then Bob comes along. He sees something. There is something hidden here. He brings it over. 7 tiny avatars are ready to be superstars. Right, so you can see how easy it is to build something up that allows people to get creative with physics, with a few additions, all of this with Mesh Toolkit and Play Mode to try it out and develop the scene. Thank you so far. Over to Rebecca.
Thanks y'all so much for watching. Check out aka.ms/meshdocs to get started with Mesh, or go to aka.ms/meshphysics to learn more about mesh physics and get access to all the samples we showed you here today. All links are in the description, and make sure to like and subscribe to the YouTube channel for way more videos about Mesh. Thanks so much.